Welcome back, Cat 5 class. In chapter 14, we're going to cover tolerancing, so how to add tolerance or wiggle room to your dimensions in AutoCAD. Next slide. Okay, so what's the summary for this chapter? What are we going to learn in chapter 14? How to create and apply tolerances to existing dimensions. Key points: tolerance parameters are set in the Dimension Style Managers window in AutoCAD. There are 3 different ways to add tolerance dimensions to your drawing. If you wanted to change your dimensions, let's say you just added dimensions with no tolerance, as shown on the preview, but let's say you wanted to add tolerances, one option is to override. So you go into your Dimension Style Manager, something we learned in the previous chapter, and you click Override, and you can add tolerance plus or minus 0.100, for example, or you can add a max and minimum. And you can update, and it'll update all your dimensions to include a tolerance attached to your dimension. Another option is to have a temporary override, and by having the temporary override, any new dimensions you create will take on the changes that you made, like adding a plus or minus tolerance. And another option you have is to create a new dimension style. You can call it a tolerance. So you can add a new dimension style, call it a tolerance dimension style, or just tolerance here in the box. Create a new one and add your plus or minus tolerances for a group of dimensions. And you can leave the other dimensions without any tolerance, and you can use the title block to define your tolerances for dimensions that don't have any tolerances attached. So if you want to add tolerances to your dimensions or some of your dimensions, well, first you go to Dimension Style Manager and you'll go to the Tolerance tab. So once again, go to your Tolerance tab and you can go to the Method drop-down. So currently there are no tolerances attached to the dimensions. So you will go to the drop-down and you can pick Symmetrical, plus or minus 0.100, Deviation, let's say plus 0.100 minus 0.050, or you can go with Limits, a max and a minimum. Or you can go with the basic dimension where you add a rectangle around the dimension and you would use your GD&T tolerances, but that's a different class. That's CAD 45. That's for GD&T, geometric dimensioning and tolerancing. Another way to add tolerances is by first selecting the dimension or group of dimensions. First select them. It'll be highlighted. Then you right click and you're going to go down all the way down to properties. So at the bottom of the list you'll have the option to change properties and a window will pop up on the left with properties. You can change decimal places, you can change, you can add tolerances, you can change units, you can change the size of the dimension, for example. Next slide. So as mentioned on the previous slide, you're going to go over to this window. And you can just scroll all the way down to the tolerance location. And again, this is a summarized version of the Dimension Style Manager. And you can scroll all the way down to the Tolerance tab or Tolerance location. And from here, you can go to the drop down and select what type of tolerance you want to add. Do you want limits? Do you want deviation? Or do you want symmetrical or even basic tolerance option? And then you can type in your tolerances for the upper and tolerance for the lower. So this is how much wiggle room you're giving, how much the machinist and inspector can be off by. And as long as the measurement falls between the basic dimension and the given tolerance, then the part is accepted. If it falls out of that range, then the part has to be rejected from the quality department. And if you want to change decimal places, you scroll up, go to the primary units, and go to precision. And from the pull down here, you can change the number of decimal places. And again, I'll walk you through it on the assignment video. Next slide. Okay, here we have a bushing. So just imagine we have this fork made out of iron. And so that the hole doesn't get damaged from wear and tear, one of the options you have is to insert a press fit bushing. So you just make this diameter slightly larger than the hole. So that way you'll have an interference fit where the hole is larger than the cylinder, or in this case, the press fit bushing. So you can force it in there, tap it in there, or you can press fit it in there with the machine. Now in this case, they didn't put a bushing, they just put a rod inside, and we have a little set screw that holds the rod. You turn the set screw, it's just a screw without a head. You turn it, and it's just so you can lock the shaft in place. And again, another option to protect this hole, or if it ever gets worn out, you can always drill a larger hole and come in with this press fit bushing, which can always be later replaced if the hole ever gets worn out. You just tap the bushing out and place a new one. And for our assignment, we're only going to do the bushing. Once again, the bushing that goes inside the hole. On a later chapter, we will be drawing the fork. And for chapter 14, once again, there's only one problem. This is the only problem for chapter 14. You're going to draw this bushing once again. Here are the diameters, diameter for the inside hole and the diameter for the shaft. And then we have the overall length. Okay, so take a look at the video and I'll walk you through it step by step on how to create this in AutoCAD from scratch. And this is just a preview of what we're going to be drawing in AutoCAD. And once again, I'll walk you through this step by step using AutoCAD and how to add our tolerances. And here's another example of inserting a bushing inside of a hole. Again, it's to avoid wearing the hole down. So you protect this hole by adding a bushing, and you allow this hole to get worn out, and you can always replace this bushing or ring. You can pop it out and place a new one. Last thing you want is to wear down this hole and having to replace the entire fan clutch.